Okay, so my circle drawn there. So I'm going to draw my regular hexagon sided. I know my regular hexagon is made up of 60-degree sides, so I'm going to do it in green here just so we can distinguish it from the other ones. So draw here, 60 degrees, 60 degrees down at that, horizontal line straight over, horizontal line over here, and then I draw 60 degrees down here, 60 degrees here. Okay, and the other piece of information, and this is the one I need now, the other piece of information I have is that the square is going to be the same height as the hexagon, and I know that the left hand side of that square is going through this right hand side point of hexagon. So we have there, it's going to be the height of the square. I can just go a 45-degree line to quickly give me the rest of that square there. So I can give me the right hand side, the diagonal through the square. I'm trying this one here. There's that. Okay, so that is a similar hexagon and square to the one I need. Now the only thing I have is A. A is correct. A is the point. A is going to be the same on this one and the old one. That's the important, or the new one. So the other piece of information I have is that it has to fit into this gap here, which means the right hand side of that square needs to be against this wall here. So I'm going to take my flashlight and shine it through A and enlarge everything. So here's A. Goes against the wall over there. Here's A here. Over here. Okay. So that gives me now the height, gives me the right hand side of the square I need, and it gives me the height of the old and the new hexagon. So I can project, gives me the height of the new hexagon. Put it over, so now I've got the height through. Okay, now remember, if we're enlarging something, the sizes change, the angles don't. So if for me the hexagon is going 60 degrees, it's still the same in the new one. So there it is, I know that's the height of it. There. To get this point up here, I enlarge it through A. So there we go. Extend it out through A. That's why my height up there. And with the height down this point here, I enlarge it through A to get it on the one. Okay, so I can draw them in. So that's going to be the base of my new hexagon. That's going to be the top of my new hexagon. Okay, going down at 60 degrees. There it is. At 60 degrees. It's there. The new square, the left hand side is going from that line to the top one, through that point, and it is in there. And I can draw in the base of that square there. There we go. Alright, so there's our new shape, the correct one we need. It's all fitting in here. I have a regular hexagon, regular square, fits in 10 from either side there, so that has to be what I'm looking for. Alright, so next thing I'll concentrate on is we'll start looking at drawing this, the plan. So it's a birthday card, which means it's a flat piece of paper. We're talking about a flat piece of paper. Well, if we're talking the plan of that, it's going to be just a line. So the line, they've told us, is just a flat line that rotates at 45 degrees. So I'll draw in that line, whatever the width is here, it's going to be the same width underneath. Take down the two lines. So I'll come down 20. Down 20. I'm drawing the plan of that birthday card, which is just a line. Okay. Now they told us that that birthday card rotates over to 45 degrees. So remember, the plan in this one is going to be the old and the new the old and the new views. So I'm going to have to take every point here onto that and rotate it around 45 degrees. So the first thing I'll do anyway is I'll draw the overall thing. Like that, 2H line. That's my compass here. So I'll rotate up my point there. I'll rotate the side around. Okay, so the width of that won't change, just its position. So that is, whatever size that one is, the same the new one. Okay, so I'll start with by bringing the overall, the outside, I would say the perimeter of the shape over here. So I need a vertical line to project everything against, so I'll just use the outside here. And I'll start projecting what I need against that. So I need, if I'm looking in at the Berta card as it turns around, that's the width I'll see there to there. So that's it projected against there. I'll bring it up to 45. Bring it up at 45. There we go. I'll drop my. So I'll draw up vertical. Line. The heights of the outside line are going to stay the same, so I can project them straight across. So before it turns into a curve, there was 2 vertical lines, and they'll still be there. There. There, right. Okay, so we have to draw this curve here. As we know, we have a semicircle up here. It's not going to be a semicircle when it starts to turn around. So we took the tape here, the circle there in the middle. If I'm looking at it at 45 degrees, that circle there is going to turn into an ellipse. Alright? So I could divide it up 60-30 into points, but remember the rule we said, if we have a half a circle or more than half a circle, we'll use the Trammell method. Okay? So to get the Trammell method, we need to find our major and minor axis. So if you imagine that turning around, that axis here, even though on a circle, the major and minor axis are exactly the same, but when that starts to turn around 45 degrees, this is going to end up being the minor axis. So I have the minor axis there. All I'm short is the major axis over there. So I'll draw the major and minor axis of, even though it sounds mad, of the circle. There's the major and minor axis. I already took them down, so there's that minor axis over there. I just need to find the major axis in its new position. So I project it down. There we go. Gets rotated. So there's the old position of it. So I'm looking down on top of the major axis there, and I'll just rotate it into its new position. There we go. So there's its new position. And I project it over. Goes up at 45 degrees. And now project it straight up. Like that. Make sure that's right. What's this? 78. Yep, that's right. So it should be right in the middle, and it is. Okay. So the height of that axis won't change. Okay. So now I have my major and minor axis over here. Alright. So there I have the kind of curve that's going into, or the major and minor axis new one. So remember, Trammell method. So the Trammell method, I'm going to mark C for the center, and then 1, C to 1 is the distance of half the major axis. So it's C to 1, and that's 1 because it came first in the competition of what's the biggest axis. What came second? Well, the minor axis came second, from C to 2. The minor axis came second. So there it is there. C to 2. Right, so we have the two of them. So now we can start constructing our ellipse. So we'll just make sure to just start. So we'll make sure that we'll label these. Right. So we said 1 and 2. So major, minor. Major is 1, minor is 2, and then we'll start turning around. So 2 stays on 1, 1 stays on 2, C is a point. 2 stays on 1, 1 stays on 2, C is a point. So we turn around. There's 2 stays on 1, 1 stays on 2, C is a point. 2 stays on 1, 1 stays on 2, C is a point. We keep going. Right, so there's my points going around. Draw that very, very light area line to give myself a guide. And then I draw in one line on my curve. And here it points up. There's my curve line there. And the last thing to do, remember, I need to show the examiner that I've used the Trammell method. I just draw a line and I just mark in the markings I had on my Trammell. So there's 1, 2, C. So 1, 2, C. Just draw in the line. Maybe. Okay, 1, 2, C. And then 5mm gap above. And nice and neatly there. Just tell the examiner Trammell method used. Alright. Okay, so that's our curve. Nice and handy. Okay, so the next thing we'll do, we'll get this S over here. So a lot of points. If I was to take all these points, so you need to be strategic here. So we've already been strategic already and going, right, instead of dividing that into 7 points, we get a major and minor axis, bring it over there and quickly whip around our ellipse. Same for this S here, right? Am I going to take across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 points? Am I going to take over 12 points? I'm definitely not. So instead of arcing around with 12 points, I'll bring over the rectangle that's going inside them, right? So I bring down the two outsides of that rectangle. I'll find them on my old birthday card, or where the old position of the birthday card was. So them two outside, that's me looking down.